Molweni sanibonani shafere unjani. I go by the name of Motizo. Mawugcwala ka lepanso la, please hit the subscribe button and like this video. Today kahle kahle re tlo re nyaka fluid properties. So yini fluid properties? Fluid properties is into those spanisang or something that you use to describe a fluid. Njega ufuna to describe a motor to me, a vehicle. You tell me a model, maybe you say it's a 200 model SLK Mercedes-Benz 3.2 liter engine. So fluid properties are things that we use to describe a fluid. Sure. So loading different kind of fluid properties, but not all of them. So loading density, specific weight, specific volume, specific gravity, and the dynamic viscosity. So what is density? Density is a ratio of a fluid mass to a fluid volume. So it's a ratio of a fluid mass. So it's mass over volume. So its unit is kg per meter cubed. That's the unit. That's density, or it's called mass density. We also have the specific weight. So the specific weight is a ratio of a fluid weight to fluid volume. So it's weight over volume. So we know weight is equal to mass by gravitational acceleration. So gravitational acceleration has a mass by gravitational acceleration. It's a force. It has the units of newtons. So volume is per meter cubed. That's the unit of specific weight. So we know weight is mass by acceleration, gravitational acceleration. So when we rewrite it, mass over volume is density. It's denoted by rho, right? And then we have, this would be rho multiplied by gravitational acceleration. So yeah. So we also have what you call a specific volume. So a specific volume is a ratio of volume per unit mass. So it's an inverse of density. It's 1 over density. It's volume over mass. Remember, density is mass over volume. So it's just the inverse of volume. That's a specific volume. So now, specific gravity is a ratio of a weight density or specific weight of a liquid to a specific weight, to the weight density of a standard liquid. In our case, a standard liquid is water at 4 degrees Celsius. So it will be the specific weight of maybe oil or mercury divided by the specific weight of our standard or our reference fluid, which is water at 4 degrees Celsius. Then there will be what we call dynamic viscosity. You need a dynamic viscosity. So dynamic viscosity or viscosity in general is a measure of the fluid resistance to flow. So the way we look at it, suppose uthatha a deck of cards, uyibheka esandleni sakho. So you have a card on your hand, your upper hand will be moving, you'll be moving, and then your lower hand would be stationary. So we assume this part as your upper hand moving in that direction, and the fixed surface would be your lower hand, right? We assume that a fluid is made up of so many layers. So now move your upper hand, the top card will have higher velocity as compared to the lower card. So when you're moving up from your bottom hand going upwards, which is a distance from a fixed surface, the velocity or the cards would move faster relative to the lower card. So dynamic viscosity is just a property that helps us to determine the shearing stress of a fluid. That's what it is. So it is a property that helps us to determine the shearing stress of a fluid. So So when you look at this graph, we have tau, which is a shearing stress, and then we have oil and water. So you see water moves faster when moving up from the stationary surface. So as related to oil, that means oil has a higher viscosity than that of water compared to water. So water has a little bit less shearing stress, but it can flow faster. Oil has a higher shearing stress as compared to water because it moves slower, meaning the internal friction between molecules is higher at oil or in oil as compared to water. Jeffrostan. I'm Audola Sevi.